Okay, we're going to solve a couple of more equations that are just mixed of no particular type. We're just going to take a look at it and see what we need to do. So in this first equation that we're going to solve, we're given the absolute value of the quantity 2x minus 3 minus 4 equal to 7. So the first thing that I notice about this is that it has an absolute value term in it. So when we've got absolute value involved, we want to set, and we just have one absolute value in this case, so we want to get that absolute value by itself on one side of the equation, and then split this into two equations, eliminating the absolute value signs. Okay, so to do that, the algebra that it would take to get the absolute value by itself is to add 4 to both sides, right? So I'm going to have absolute value of 2x minus 3 minus 4 plus 4 equal to 7 plus 4. Okay, so I'll have absolute value of 2x minus 3 equal to 11. Okay, so now that I have the absolute value equal to a number, I'm going to separate this into two equations and eliminate the absolute value signs in doing so. So I know that 2x minus 3 could be positive or it could be negative, right? So here's how we take care of that. We're going to have 2x minus 3 equal to negative 11, or 2x minus 3 equal to positive 11. Okay, in both cases, I have to add 3 to both sides, right? So with this first one, I'm going to have 2x minus 3 plus 3 equal to negative 11 plus 3. All right, so now I have 2x equal to negative 11 plus 3 is negative 8. And then I want to divide both sides by 2. So x is equal to negative 4. Okay. Now over here with 2x minus 3 equal to positive 11, I also want to add 3 to both sides. So plus 3, 11 plus 3. So I have 2x, so 11 plus 3 is 14. And then I need to divide both sides by 2. So x is equal to 7. Okay, I have two solutions there. And I want to check these. So into the original equation, I'm going to have 2 times negative 4 minus 3 minus 4 equal to 7. Is that a true statement? So 2 times negative 4 is negative 8 minus 3, okay, inside the absolute value, minus 4 equals 7. Negative 8 minus 3 is negative 11. What's the absolute value of negative 11? Positive 11, right? Minus 4, is that equal to 7? It is. Indeed. Okay, so let's try the other solution of x equals 7. So absolute value of 2 times 7 minus 3. And then outside the absolute value, I'm going to have minus 4 equal to 7. Okay, is this a true statement? 2 times 7 is 14. 14 minus 3 is 11. What's the absolute value of 11? Just 11, right? Subtract 4, do I get 7? Yes, I do. Yeah, so both of these work. So the solution set is negative 4 and 7. Okay. All right, so that's a great reminder. When you have absolute value, especially when there's just one absolute value, get the absolute value by itself on one side of the equal sign and then split it into two equations where you account for the fact that the stuff inside the absolute value could be positive or negative. Okay, let's look at this next example of 2x squared plus 12x equal to negative 4. Okay. So again, I see that x squared term. We've done so much factoring. I'm thinking, yeah, it's a quadratic. I want to set it equal to 0 and see if it factors. That's the first thing I'm going to try. All right, so to do that, I have to add 4 to both sides. 2x squared plus 12x plus 4 equal to negative 4 plus 4, right? Keep it balanced. Okay, so I have 2x squared minus 12x plus 4 equal to 0. Okay, so I notice that the leading coefficient is not 1, But I also know that that 2, that coefficient of 2, divides 12 and also 4, right? Everything there is even. So I can pull a 2 out. Always look for that if there's a GCF that you can pull. So I have 2 times the quantity x squared minus 6x plus 2 equal to 0. Okay, so now my question would be, does x squared minus 6x plus 2 factor? Well, let me see here. I'd have to have factors of 2 that add to negative 6. The only factors of 2, if they both have to be negative, would be negative 2 and negative 1, and that adds to negative 3. So this doesn't factor, right? Okay, so if it doesn't factor, does that mean it doesn't have a solution? Well, not necessarily. Just because it's prime doesn't mean that it doesn't have any solutions. What are the other options that we have for solving x squared minus 6x plus 2? Well, because it's got a middle term, I would go to either the quadratic formula or completing the square, okay? So we're going to review both here. I just want to run down. Okay, first of all, what is the quadratic formula? It's been a while for some of us. We haven't really reviewed it in this class, but you should know what it is. Okay, so for any ax squared plus bx plus c equal to 0, if we want to solve that, factorable or not, we can use this quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. I understand that there's a song that goes with this if you learned it somewhere, Pop Goes the Weasel, what have you. I kind of like the little storyline that goes along with it. With a negative b, a negative boy was iffy about attending a totally rad party. He could be squared or miss out on 4 awesome chicks and not be home until 2 a.m. Whatever you want, however you want to remember that, it's it's good. But anyway, a reminder of what that formula is all about. Now, so using that, like in this particular instance, our a value in this case is 1. The b value would be negative 6, and c would be 2, right? So if we use the quadratic formula, we would have x equal to negative b, so we'd have a double negative there with a negative 6 in the mix, plus or minus the square root of negative 6 squared minus 4 times 1 times 2, okay, all over 2 times 1. Okay, so let's clean this up. We're going to have positive 6 plus or minus the square root of negative 6 squared is 36, and 4 times 2 is 8, right? All over 2, okay. So then we have 6 plus or minus 36 minus 8 is 28, right? So we have plus or minus the square root of 28 over 2. Okay, now in that 28, does 28 have any factors that are perfect squares? Right? Well, in here, 28 is 4 times 7, right? So what's the square root of 4? Well, 2, right? And then we'd have a 7 left over underneath there. Okay, all over 2. Okay, 6 over 2 is 3, right? And 2 over 2 is 1, okay? So I end up with 3 plus or minus the square root of 7. Okay, all right, so this is a totally acceptable way to do it, and we notice with the square root 7, that's an irrational solution. That's why we couldn't factor it, right? Okay, so we know that x is equal to 3 plus or minus the square root of 7. We could check that, very cumbersome to check, of course, with an irrational solution. Instead of checking it, I'm going to do it with one more method. I figure if we can do it with the quadratic formula and by completing the square and we get the same thing, chances are we know what we're doing, right? Okay, so let's try it. Let's try to do this by completing the square. So I've got x squared minus 6x plus 2 equal to 0. Okay, to complete the square, I want to get x squared minus 6x by itself. So I'm going to subtract 2 from both sides. 2 minus 2 and 0 minus 2. Okay, so I'm going to have x squared minus 6x equal to negative 2. Okay, now if we're going to complete the square on this, what do we need? We've got to take 6, divide it by 2, and square it, right? What does that give us? Well, 6 over 2 is 3. 3 squared is 9, right? That's what we need to give us the perfect square trinomial. Now, what you do to one side, you got to do to the other. So when we have x squared minus 6x plus 9, that's a perfect square trinomial, right? And the square root of 9 is 3, and the middle term is negative, so we're going to have x minus 3 quantity squared equal to, let's see, negative 2 plus 9 is 7. Okay, so now, did everybody follow that? So if you didn't notice it as the perfect square trinomial that it is, you can always ask yourself, what are factors of 9 that add to negative 6, right? In this case, it's negative 3 and negative 3. Now, the purpose of completing the square is to form a perfect square trinomial. So you know you're going to have the same binomial squared, x minus 3 times x minus 3. Okay, so now we're going to take the square root of both sides, and you got to remember the x plus 3, it could be positive or negative, so we've got to have the plus or minus square root 7. So we're going to have x minus 3 equal to plus or minus square root 7. And, of course, we have to add 3 to both sides, right? So x minus 3 plus 3 equal to 3 plus or minus square root 7, right? I'm going to put it up front there. Okay, so we're going to end up with x equal to 3 plus or minus square root 7. Now, did we get the same thing as when we used the quadratic formula? Yes! And in fact, if you take ax squared plus bx plus c equal to 0 and you just complete the square on that with just the variable coefficients a, b, and c, you get the quadratic formula. You're actually doing the same thing. Now, some people like just to memorize the formula and have that and know that, and that's fine. Some people prefer completing the square. Depending on what you have, it can be more cumbersome to do one or the other. So when you look at the work that I showed for both of these methods, both the formula and also completing the square, they're similar, actually. You know, people think it's so much harder to complete the square. In some ways, it's much easier, and there's less to remember about it. Honestly, you've got to remember this big old long formula with quadratic formula. So when you're given a quadratic that doesn't factor, it's acceptable to use either method, the quadratic formula or completing the square, to get it solved. Okay, so the solution set here, we really have two solutions for x, right? We have 3 minus the square root of 7. And we have 3 plus the square root of 7. And we could also stick that into our calculator and get a decimal approximation that would be approximate. If the problem doesn't specifically ask for it, I think it's a lot easier just to write the exact form. Okay, great practice and review of quadratic formula and completing the square and also solving absolute value equations.